Hello, everyone. A very warm welcome to all of you. We welcome you to our live simulation of our project, what we have done while pursuing our embedded systems in internship in Emertxe Information Technologies. I would first begin with the introduction of my team. The first member is Ravi Prakash, which is me, and the another one is Vishesh K, which is one of my batchmates, and as well we are colleagues in this internship. We both are students from the BMS Institute of Technology and Management. So today, the flow of this presentation would be like this. First one, I would request Vishesh to introduce you to the overview of what we have been doing work overall. And another one, we will be elaborating towards the tools that we have been using throughout this internship. The third one, the main component of this program or the main component of this device, that is the microcontroller that we have used, and some salient features of the same microcontroller. Then we would be proceeding towards the methods what we have used to build the project, and then we'll have a live simulation demo of the system that we have designed, and finally we will be concluding. So now I request Vishesh to please introduce you to the entire project. Yeah, Vishesh, the next slide should be yours.
Yeah. So welcome to everybody. You can slide to the next one.
Sure.
Yeah. So as we know, embedded systems, it is nothing but a combination of hardware and software, which is mainly intended to do some specific task. And one of the main devices through which we can obtain such particular feature is with the help of microcontroller, which is nothing but an integrated circuit capable of being programmed to perform certain specific tasks. So we can use it in washing machine, refrigerator, etc. So these are some of the few applications. So our project is mainly focused on washing machine simulation. So here we are mainly specifically using PIC microcontroller, and the part number is PIC 16F877877A. Uh, yeah, so this is the overall project idea on which we are working on. Now, my friend Ravi will be carrying forward to give some overview about the tools which we have used to build this.
Yeah, so throughout this internship, we have been learning about, and afterwards being trained about the same tools. We have been using them in our projects as well. So, in a very total overview, we can say this was a virtual internship. So we have been using the various softwares associated with the programming as well as the use of the device, that is the PIC16F877A microcontroller. In order to program the microcontroller or in order to design the device, we have been using the MPLAVX IDE, which supports embedded C programming language, and which using which the same we have programmed our device, and that is getting compiled with the help of XC8 compiler. And in order to simulate, we have been using the Pixim Lab, which is a live simulator, which in where we can simulate various microcontrollers such as PIC microcontrollers, Arduino microcontrollers, and etc. Particularly for our purpose, it is suitable to get all the components assembled on the single board. In order to make it more interactive, the device to more interactive with the users, we have integrated a CLCD LCD screen over the board, which would be greeting you with the all the instructions, and such that it would become very easy for a normal layman person to run this washing machine. And there is a fan also attached in this board, which actually functions to reduce the heat and lower the temperature of the device, so that there is no harm to the uh, washing machine machineries. And as well, it indicates the running of the motor, as we can't see the motor which is being integrated inside, but we are having a virtual overview of this thing. So these are the various tools and components which we have used. So now I would request
Yeah.
Vishesh. So please elaborate them about something about the PIC microcontrollers.
So yeah, as we are specifically using a PIC microcontroller in this particular project. So before going on to the live demonstration of the project, I would like to give a few insights about TPIC microcontrollers. So it is the world's one of the world's smallest microcontroller that can be programmed to carry out a huge range of tasks. So these microcontrollers are found in various electronic devices like phones, computer control systems, alarm systems, and then there are various other microcontroller which exist. But these microcontrollers are programmed and simulated by a circuit wizard software. So as we can see, this big microcontroller is a 40-bit microcontroller, and the remaining, and we'll be discussing about the features of this microcontroller in the coming slide.
Okay, so specifically within throughout the range of big microcontrollers, we are using PIC 16F877A, which has the salient features listed out over the screen. I would like to recall them once. So basically, we are having a 8 kilobytes of code space. We can write 8 kbs of space. And again, we have electrically erasable and programmable ROM, which has a capacity of 256 bytes. We have a static RAM with a capacity of 384 bytes. And again, we have a 8 level deep hardware stack. There is a clock associated inside the board. There's a clock associated inside the this 16F877A microcontroller, which has the highest frequency ranging up to 20 megahertz. At the same time, we are supported with three different timers, one with the 16-bit capacity, while the two other ones with 8 bits each. We have synchronous serial port, that is SPI and I2C. There is an architecture associated which is USRT. There are totally 8 channels, and we have a ADC, that is analog to digital converter, with the capacity of 10 bits of data. There's a brownout reset button as well, which basically indicates we can reset the microcontroller throughout a single instruction. We have two analog comparators. Then we have the where again we have been supported with the capture, compare, and PWN modules as well. So these are some of the salient features of this microcontroller that we have been using in this project. Yeah, so next would be the methods, but methodology we have used in order to design this automatic washing machine. So basically, uh, it has various stages of implementation. As we can see, we have listed over the screen as well. So a normal washing machine, layman user, I just want my washing machine to have some basic washing functionalities associated, such as a daily wash, or maybe a heavy wash, or maybe a stain wash. uh, you know these should be available as an option in the very beginning stage, with that when I'm switching on my machine, I should be comfortably able to choose which mode of washing I want to choose for my clothes. In order to in order to conserve the various components, we have minimized the use of switches. So the same switch we would be using to toggle between different washing modes through a regular press, while the same switch, if you press for a little bit longer period, say twice or thrice longer period, you would be able to select that particular washing mode, and you would be uh, you know facilitated towards the next stage, that is you would be able to select the water level as per your cloth needs. Once we have selected the water level as our requirements, we can move to start the operation selected. Again, we are having an option to move back, I mean return back to the previous stage if mistakenly any wrong operation has been selected. Say I'm putting in woolen clothes, and by mistake I have been selecting cotton mode of for the washing. So in order to go back at the same stage, after selecting the water level, I have an option to toggle back to the initial stage. After I've selected to start the operation, it runs for the specified time as what it has been programmed to. And once the operation has been done, it will indicate by the stopping in the rotation of the fan, and as well a buzzer sound would be indicating that the program has been completed. And in order to avoid any kind of damage to the machine, if say in between by mistake and anyone opens the door, the machine would be stopped immediately. It would stop running, and the buzzer sound would come up indicating that there is some malfunctioning, so that the user can bring their attention back towards the machine, and they can get that the door has been opened. So this is the very basic idea, or the very basic method we have, what we have used to design our machine. Okay, so now let's have a live demo of the simulation for the device. I would first let you go through the code what we have written, and then we will be having a look over the our this thing. So this is the code. As you can see, we have totally classified this code into the different components what we have used, and accordingly the very basic functioning or mechanism have been written in their separate files. Say for the LCD screen, we have created a separate file where we are writing separate modules or separate functions for their functioning. Suppose we are going to write a long statement, we are using CLCD underscore write function. And again, if we are going to write the single character over the screen, we can use this function called as cd underscore put ch. These names we have given by ourselves in order to bring ease while writing and reading the code, so that we can easily underscore. Again, this in order to print a long string over the screen, we can use the clcd print function. The init CLCD, which is the initialize CLCD function, which is the basic commands to switch on the CLCD device, and this controller function has been used to to control the printing, like in order to bring about a synchronous printing over the screen. Similarly, for keypad, I mean the switches what we have been using, we have written this particular file in which we have first we have initialized the keypad, and again after pressing a particular button we are reading the signals, or we are reading the commands what has been passed on to the microcontroller through the electrical signals being imparted. Again, with for the timers which we are using for while calculating the time, we have written this thing, again a function separately, and all of them have been assembled in this main.header file, in which we can see we have included all the respective header files for all the different components. And finally, this main header file has been included in this main program. Again, this we have designed the basic functionality of each and every component separately through their files. Now, in order to bring about them synchronous about as per our need, I mean, in order to use different components as per the need of this washing machine, we have elaborated through different cases, like having if and else conditioning, and while and the looping constructs. We have written the basic code. So this is the long code what we have written for the designing purpose. Now Vishesh would be elaborating towards the live simulation. Vishesh, are you there?
Yeah.
Yeah,
So you can just.
yeah.
So in order to simulate our project, we have basically used a Pixin lab. So which is nothing but the uh, virtual key format of our development kit of a PIC microcontroller, which we are using to build a washing machine. So yeah, so beginning with we'll be basically clicking on the RB4, which is nothing but switch 5, to in order to initiate our washing machine program. So you can just
Just
so
reset
yeah.
this so that it goes from the beginning. Yeah.
So So once you click on this, we can see a welcome information on this. So once our this switch 5 is pressed, and after the welcome information is given, we are given with a list of washing programs. Depending on the user's requirement, he can choose the specified. He can choose whatever program he wants. He can choose whatever mode of his washing machine has to be run on. So for demonstration purpose, we'll be using the heavy washing program. So yeah, you can just long press on that particular program.
Yeah. Yeah. Again, as Vishesh mentioned, if we want to use the program which has been omitted from the screen, don't worry, we can get that back as long as we keep on pressing this single times. It will be scrolling back towards the bottom, and again we will be thrown back towards the beginning for options like daily and heavy. So let's just keep them pressing once by again and again. We will be taken back. So
Yeah. So these are the basically the available washing programs which we have included in our particular project. So based on the requirement, the user can select any of the thing.
So
So
as you
yeah, after
mentioned,
since
yeah,
we are demonstrating this particular project, so in this we are basically gonna use the heavy mode. So in order to select it, we are gonna long press switch 4, which is nothing but RB3 in a particular development kit. So you can just long press Ravi.
sure.
Yeah. So now after the washing program is selected, the next thing which the user has to select is the water level. So here we have given the level like auto, low, medium, high and maximum. So depending on the requirement, the person can choose. So in our particular case, we'll be using the auto mode. So in order to select it, again, we are gonna long press switch 4. So yeah, so after the long press, we can see, we can also like if the user has by mistake he has chosen some wrong program. So there's an option to go back, that is switch 6. If he clicks on, he has the option to revert back to the washing program. So if you can just click on that, yeah, RB4, RB5. Yeah, so as we can see, he's again been displayed all the programs which is available. So now in order to show the further process, we'll just go on with the normal flow. So you can just long press Ravi again.
Yeah, heavy or Delhi?
Heavy, yeah, whatever, daily you can click.
Okay.
And again long press for auto. Yeah, so in order to start, we are going to press switch 5, which is nothing but RB4 in our particular case. So you can just press. So yeah, here we can see that there is a timer. There is basically a timer which has been initiated. So as soon as we press switch 5, we can see the timer has been initiated, and for each program, the time has been already presetted. So for this particular case, we can see for daily we have set it to 41 seconds for demonstration purpose. So the moment it decrements from 41 seconds to 0 seconds, a buzzer will basically buzz, and then the fan will automatically turn off, and that will basically indicate that the overall process has been completed, and it will it will give a concluding statement, that is your program is being completed and you can remove your clothes from the washing machine. So as we have heard that the buzzer has already buzzed, and this is the overall project which we have worked on. So in order now we would like to conclude with the presentation. So as we know that we have designed, we have tried to mimic a particular washing machine using this PIC 16 F877E. So this overall implementation, it includes various stages where we have considered the basic requirements which the user basically requires when he's going to purchase any washing machine. So this is just a simulation. We can try to convert it into a real-time hardware system. So yeah, so this is the overall project and we would like to conclude it.